Hello everyone, my name is Vladimir Ivanov and it's Architecture Weekly number 192. The great software quality collapse, unconventional PostgreSQL optimizations, explicit architecture and many more in today's issue. Software quality has been degrading for years, and it's not just an AI problem. Apple Calculator leaking 32 gigabytes of RAM, CrowdStrike crashing 8.5 million machines due to missing bounce checking, Teams consuming 100% CPU. The industry is spending roughly $364 billion on infrastructure to compensate for engineering failures instead of fixing the root causes. The AI-generated code era, with its 300% more security vulnerabilities, only accelerates the trend. So what we're all gonna do about it? The next article is about explicit architecture, domain-driven design, hexagonal, onion, clean, secure S. How do we put it all together? So in this article, there's a comprehensive synthesis of major architectural patterns into one coherent model. Instead of treating ports and adapters, onion architecture, domain-driven design, and secure S as separate concepts, the author combines them into three fundamental blocks: user interface, application core, and infrastructure, with all dependencies pointing inwards. Try it out the package by component approach, organizing code by business domains rather than technical layers. I would like to present you the unconventional PostgreSQL optimizations. So, three creative PostgreSQL optimization techniques beyond the usual indexing advices includes the following. First one is constraint exclusion to skip full table scans when query conditions contradict check constraints. Then function-based indexes, reducing index size from 214 megabytes to 66 megabytes through the duplication. And the last one are hash indexes for uniqueness enforcement on large text columns, consuming 5 times less space than B3 alternative. Strategic use of PostgreSQL lesser-known features can dramatically change performance characteristics. And the last one in the follow-up section is why spec-driven development can be iterative, incremental, and agile. So spec-driven development is not waterfall. The author of this article argues, though, that it iterates on understanding rather than solely on code. Short, focused, markdown-based specifications stored in version control and treated as living documents. Without clear specs, developers guess and AI confidently generates the wrong code. The system grows use case by use case, and the time invested in writing a clear spec is saved multiple times during the implementation. And that's it for the highlight, and we're switching to the follow-up sections, where the first article is about Bolt, where I was working for 3.5 years myself. And I was fortunate enough to witness the migration from MySQL to TitaniumDB at Bolt. Several years ago, we hit severe scaling limits with MySQL at 100 million users. Can you imagine? Adding a column to a 1 terabyte table might took a week, literally. After working with Vitess for a while, we migrated to TitaniumDB from its MySQL wire compatibility, horizontal scalability, and strong consistency via Raft consensus protocol. The results: 3:1 data comparison ratio, so 3 terabyte MySQL to 1 terabyte TitaniumDB, 35,000 queries per second for all the clusters, and 7 clusters supporting core business services. The migration went smooth well too, so each team migrated at their own pace, and we completed the whole one in like a year. Speaking about the databases, the Spreadsheet engine is like a database itself, and building it from scratch, Grid built one of the most sophisticated spreadsheet engines that runs entirely in the browser. The complexity is staggering, truly. Excel has 510 functions, Google Sheets 494, and together there are 600 plus unique operations to implement. A spreadsheet is essentially a program where users declare relationships in a 2D grid, and the engine must maintain deep dependency graphs with thousands of relationships. Their engine covers 398 functions, handling 99% of real-world spreadsheets. Back to the LLM and the AI topic. Without benchmarking LLMs, you're overpaying. Generic LLM benchmarks like GPQA or AMLU don't predict performance on your specific task. The author of this article, though, benchmarked actual customer support prompts across 100 plus models via OpenRouter and found there are cheap alternatives delivering comparable quality, cutting costs by 80% and saving over 1,000 monthly. The key? Collect real examples, define expected outputs, and score results using LLM as judge rather than trusting marketing leaderboards. And the last one, like a cherry on top of this issue, is the article by Mark Brooker named "You Are Here." Mark Brooker argues that AI has drastically reduced the cost of writing code, which is indeed happened, but building reliable end-to-end systems still remains hard. He frames it though Amdahl's law. Massive speedups in one area yield diminishing returns unless other bottlenecks are addressed, which sounds quite familiar to the theory of constraint, right? The real opportunity lies not in clinging on traditional programming, but in leveraging AI tools to solve previously intractable integration and system design problems. So software first era has ended. Thank you very much, and thanks everyone who is supporting this YouTube channel and the newsletter. You can join this group by subscribing to Patreon or supporting the newsletter on the Substack itself. Thank you very much, and see you next week.